Hi, my name is Olivia Putnam. I'm a second year at The Ohio State University in the Chemistry and Biochemistry department. Over the summer, I conducted chemistry research at the University of Puerto Rico, REU through the PR-Climb REU program. My project focused on deactivating a protein called RAC1. RAC1 is a key contributor to metastasis in a lot of different types of cancer because of its signaling for cell migration. My role was to synthesize drug derivatives of a potent RAC1 inhibitor to keep the protein from activating. So over the summer, I synthesized 15 different drug molecules to bind to one of its binding pockets. And if you think of synthesizing molecules like baking, you put a bunch of ingredients together to produce a new product. So I needed to find different spices to make this molecule better. So these spices were different functional groups that I added around a base triazoyl ring. And through doing different combinations of these different spices, I was able to find different combinations that made the drug more effective and was able to deactivate the protein better.
Hello, my name is Daniel Gomez, and I'm a high school senior at St. Stephen's Academy in Beaverton, Oregon. Last summer, I had the honor of participating in the REU PR-Climb program at the University of Puerto Rico, Rio Piedras, where I was able to research aqueous or water-based batteries. In our research, our main goal was to replace normal lithium-ion batteries with these water-based batteries because they are very cheap and also very safe. However, these batteries can't hold as much energy inside them, meaning they're not as powerful as the typical lithium-ion battery. Because of this power problem, our research focused on finding the missing spices that we would need to add to the aqueous batteries in order to make them much more powerful. During our research, we found the missing spice to be a type of copper salt that made our batteries much better at holding energy. This discovery was very important because we need strong aqueous batteries to replace lithium-ion ones, because lithium is very expensive and also very dangerous. With these spices, we can make energy storage not only less expensive, but much safer for everyone.
Hello, I'm Sabrina Fernandez. I'm from Clemson University and I'm in the Department of Chemistry. This summer through the PR-Climb REU program, I worked on developing gold nanoparticles using natural polysaccharides from algae. And the theme for National Chemistry Week is the hidden life of spices. So I'm going to discuss some of the missing spices in my project. These missing spices, we're trying to find the right natural polysaccharides that could be used to stabilize and even enhance gold nanoparticles without the use of harmful chemicals. To do this, I experimented with 3 different types of algae bases. These were alginate, carrageenan, and olivine, and I wanted to see how each one affected the nanoparticles' color, stability, and size. I then used electrochemistry to study how these coated nanoparticles behaved at the surface of an electrode. By understanding how these natural coatings interacted with gold, we can design renewable nanomaterials that could be used for future chemical applications. So just like in cooking, chemistry lets us find the right blend of ingredients to make something truly powerful, even at the nanoscale.
Hi, my name is Aiden Gazda, and I'm a junior at the University of Illinois Urbana-Champaign studying chemical and biomolecular engineering. This summer, as a part of the PR-Climb REU program, I worked in the Kunze lab to develop a wearable prototype of a sensor that could detect and measure a certain biomarker's concentration in sweat samples. So basically, the missing spice that my project was addressing was a piece of wearable biotechnology that could non-invasively detect said biomarker for diagnostic purposes, as opposed to having to use invasive routes such as blood tests.
Hi there, my name's Owen Borden, and I'm a current second year at The Ohio State University studying chemical and biomolecular engineering and pharmaceutical sciences. In biological processes, one hidden spice that we often overlook is inorganic materials. Metals actually play a huge part in our day-to-day lives, mediating so many processes that happen inside of our body. Metals like iron and copper are also really important in diseases like cancer and for cancer's progression. The research that I did over the summer in Dr. Arthur Tinoco's lab centered on a drug called diphenhydramine. Diphenhydramine is a strong chelator, which means it's a compound that binds and sequesters metals such as iron and copper. I helped to further understand how diphenhydramine interacts with both iron and copper within a cancer cell, as well as prove its efficacy as an anti-cancer therapy through exploring new delivery mechanisms such as protein binding. My work helped to shine a light on the hidden spice of metals within medicine.
Hi, my name is Shivani Trivedi, and I'm a sophomore majoring in biochemistry and Spanish at Mercer University. This summer, I had the pleasure of participating in the PR Climb REU under Dr. Surangane Dharmawardane at the University of Puerto Rico's Medical School. Our research focuses on finding the recipe for an anti-metastasis cancer drug. Through collaboration, we've created MBQ167, which is just that. But each time we find an effective drug, we change it up a little bit. Add a little more salt, a little less pepper, and eventually we'll find the perfect combination of spices to create an even more effective drug. By tweaking and refining each time, we hope to create the most effective anti-metastasis cancer drug possible.